Before you watch this video, you should be doing this exercise on the first page of your packet on your own and answering the questions. Once you've answered the questions, you can go back and unpause your video and watch the rest of it. Okay, in your triangles, you should notice a relationship between the sides and the angles, okay? So you should have seen that there's a relationship between the length of the side and the sides of your angle. So here, in this red triangle, okay, we identified that this red line is the longest side. If you were to measure, this would be the longest side, like you did in your triangle, okay? And then this red arc indicates the largest angle. We'll notice that the longest side and the largest angle are opposite each other. So the largest angle is opposite the longest side. Okay, same goes for the shortest side and the smallest angle. The smallest side is opposite of the smallest angle, or the smallest angle is opposite of the shortest side. Okay, so theorem 510 tells us exactly what we just talked about. If one side of a triangle is larger than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Okay, so here, if 8 is our largest side, we know that angle C must be our largest angle. If side 5 is our smallest side, then we know that angle A must be our smallest angle. Okay, so AB is greater than BC, therefore the measure of C must be greater than A. Pretty much what I just said. Okay, theorem 511 tells us if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Okay, so same goes for angles as we did for sides. If this angle A is 50 degrees, and let's say that this is the largest angle, then side BC is going to be the largest side. If angle C is our smallest angle, then this side AB is going to be our smallest side. Now, we don't know what angle B is. We could figure out what angle B is and then determine which one is your biggest angle. So here, B would be your biggest angle, but we're just looking at angle A and angle C. So the measure of angle A is greater than the measure of angle C. Therefore, BC is larger than AB. Okay, the last question, or question 3 said, why do you think that is? Well, if you look at it, if this angle is really large, okay, we need something that's going to connect this side of my angle to this side of my angle. So if this angle is the largest angle, my rays that are coming out of my angle are going to be farther spread apart, and you're going to need a longer side to connect those two rays, or in this case, to make this triangle. Okay. The last question was, do you think that this relationship relates to all types of triangle? And the answer for that is yes. Okay. On the next part, right below these notes, you're going to discover this on your own. Okay, these relationships apply to all triangles. You're going to draw, let's see, go to the next slide. You're going to draw the following triangles. So you're going to draw an acute triangle, an obtuse triangle, a right triangle, and a scalene. You're going to indicate the longest side and the largest angle, and you're going to indicate the shortest side and the smallest angle. So take a minute, pause the video, grab some color pencils, and do this. You should also be answering what happens in equilateral triangles. So pause the video and try to draw an equilateral triangle and think about the properties of an equilateral triangle. What about their sides and their angles? Okay, which side is going to be the greatest, or is there going to be one? Pause the video and take a second to think about this. Okay, so in an equilateral triangle, right, all of the sides and the angles are, well, all the sides are congruent and all the angles are congruent. So if all the sides are congruent, we don't have a side being the largest. And if all the angles are congruent, because all the sides are congruent, then we don't have any angles that are the largest. So we can't really indicate what's the largest side because they're all the same. Alright, next we want to look at listing the sides of triangle RST in order from shortest to longest. If we look at these angle measures, okay, they tell us something about the length of our sides. So angle R is the smallest angle measure of 29 degrees. Therefore, this side ST is going to be our smallest side. Here, angle 30 is in between 29 and 121. So this is going to be our second smallest side. Angle 121 is our largest, so this is going to be our largest side, RT. So list the sides in order from shortest to longest. Our shortest side, we said, was side ST. Okay, then the next one we go to is side RS, right across from angle 30, and the largest side across from our angle S of 120 degrees is side RT. Okay, a right triangle has sides that are 6, 8, and 10 feet long and angles 90 degrees, 37 degrees, and about 53 degrees. Sketch and label a diagram with the shortest side on the bottom and the right angle at the left. Okay, so I'm going to make my right triangle. Let's see if I can. Okay, so I have my, I had it right there first way. My right angle I want to have at the left. Okay, so here's my right angle. Okay, well, if this is a right angle, it's 90 degrees. And one of these is 37 and one of these is 53. Okay, so if this is 90 degrees, this is my largest angle, right? I have 90, 37, and 53. So if this is my largest angle, right across from it must be my largest side. My largest side between 6, 8, and 10 is going to be 10. So my hypotenuse is 10. Sketch, label, and diagram the shortest side at the bottom. Okay, so I got to have the shortest side down here. My shortest side is going to be 6. So therefore this has to be 8. Okay, well, across from my shortest side should be my smallest angle. Okay, so in here my smallest angle should be 37, which leaves me with 53 for this angle. Okay? Alright, now we're going to start talking about the lengths of the sides, okay? Not every group of 3 segments can be used to form a triangle. The lengths of the segments must fit in a certain relationship. Okay, here's an example. For example, 3 attempted triangle constructions for sides within given lengths are shown below. Only the first set of side lengths forms a triangle. So here we have a 4, 5, and a 2, a 2, 3, a 2, 5, and a 2, and a 3, 5, and a 2. If you take notice to this one in particular, you can kind of tell that if this is 5, this is 2, and this is 3, it's not going to work because this side plus this side is 5. So that would be 2 straight lines. So that's not really going to work. So let's look at why. Okay, so here we have this side is 20, this side is 3, and this side is 2. We want to look at why this won't make a triangle. Okay, if I animate this, you see that when these 2 lines move, they never intersect each other. Okay, so if they're never going to intersect each other, they're never going to come together to form this triangle here. Let's look at the next one. Alright, here I have we're trying to make a triangle out of a length that's 14, a side that's 6, and a side that's 20. Now let's animate these points and see if they're going to intersect anywhere. Okay, notice how they never touch. Right here though, they do overlap, but they're overlapping on this line. Okay, so let's see if I can get this to land perfectly. No, I can't get it. So if I were to drop this point all the way down, and I were to drop this point all the way down, They intersect, but they intersect right on this side of 20. And the reason for that is because 14 plus 6 is 20. So these two sides added together equals the length of that bottom triangle, or the bottom part of this triangle that we were trying to make. Okay, so we kept this 20 the same again, but now we're going to try 12 and 10. Let's see, these added together equals 22, so we know it's going to be larger than this 20, so it won't make another flat line. Let's animate these points and see what happens. Okay, notice how right here in the center, this is where these two lines are intersecting each other. Okay, so this is kind of what you do with your protractor. We'll look at this a little later. So if I stop these points and I drag this 12 down to that point where my two arcs are intersecting, and I draw this 10 down to where those two arcs are intersecting, you see that they meet. Now I have this triangle. Okay, so a triangle with side 12, 20, and 10 will form a triangle at this point right here, whatever this degree measure is. It's where these two arcs intersect, which we'll look at a little bit later with our protractors. Okay, so this leads into theorem 512, the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So here, AB plus BC must be greater than AC. Okay, that's where these arcs come in. AC plus BC must be greater than AB in order to, if you kind of look at it, if AB and AC are smaller, they're never gonna meet, just like this one right here. 2 and 2 is 4, which is less than 5, so they're never gonna meet. Okay, so that's the triangle inequality theorem. The two sides across from the third side must be bigger than the third side. Okay, a triangle has one side of a length of 12 and another of a length of 8. Describe the possible lengths of the third side. Okay, so let x represent the length of the third side. Draw diagrams to help visualize the small and large values of x. Then use a triangle inequality theorem to write and solve inequalities. Okay, so we know that one side length is 12 and the other side must be 8. So we know that the third side must be greater than 8 plus 12, which is 20. So we can do small values of x and we can do large values of x. Okay, so we can have 12 on this side and 8 on this side. Okay, they're both on this angle. They both are on the rays of this angle. Or we can have them on the larger side to make this a larger value of x. Okay, so if we do, if we look at these two and we make 12 the largest side of the triangle, something plus 8 must be greater than 12. Okay, so this side plus 8 must be greater than 12. So if you do it that way, x should be greater than 4. If you make x the largest side of your triangle, then you're going to add 8 plus 12, and you're going to set it greater than x. So 8 plus 12 is 20, so 20 must be greater than x, or x is less than 20. Okay, so you could look at this a couple of ways. Depends on how you look at it. So the length of the third side must be greater than 4 and less than 20. Okay, try this one. A triangle has one side of 11 inches and another side of 15 inches. Describe the possible lengths of the third side. So you could set this problem up the same way as this problem. Pause the video and do that on your own. Okay, now you're going to take the remainder of this station time, and for homework, you're going to finish the problems that are in the rest of this packet. So you have all these, and the rest of those. Make sure you're asking me questions on things that you don't understand. You could also use your textbook. This is section 5.5. This will be on your tests on Friday.